Hello, and this video is going to go through the chocolate and Nobel Prize example that's given in the discussion board. It uses simple linear regression. It's called simple linear regression because there's one dependent variable and one independent variable. Next week we'll do multiple linear regression, which is one dependent variable but more than one independent variable. In StatCrunch, the menu trail is going to be stat, then regression, and then simple linear. Again, I can't emphasize this enough. We are beyond the position where doing these calculations by hand is something that's realistic. You use the computer to do those calculations. You need to interpret the results, but use the computer to do those calculations. So here's the example in Blackboard. We'll go into MyMathLab to open up StatCrunch, sign in, go into our class, select StatCrunch. And now I've been having trouble opening StatCrunch, even clicking on datasets from your textbook. It just doesn't seem to come up for me. Not a problem. There's a link down here that says Open in New StatCrunch, so I'll click on that. The functionality is the same as the old StatCrunch. Things are in a little different area. You don't have to click through as many windows in the new StatCrunch, but everything's there. So let's look at this. I wonder the following. Is there a relationship between the average amount of chocolate eaten in a country and the proportion of Nobel Prize laureates it has? So the first thing I have to do is get the data in there. Go back to the discussion. I'm going to highlight all the data. Control C because I use Windows. For Mac people that would be Command C. That copies what's highlighted. And I'm going to paste it into this. Paste is Control V or Command V. So Control V, all that data just got popped in there. And just to make things tidy, I'm going to change the variable names. The first one is country. Second one is Nobel Prizes. Technically, it's Nobel Prizes per million. And the third one is chocolate consumption. And technically, it's the average chocolate consumption in number of bars per capita. So let's do the linear regression. Stat, regression, simple linear. And again, it's simple linear regression because there's one dependent variable and one independent variable. Now, if you're using the old StatCrunch, you'll have several windows that you click through. X variable is going to be the chocolate because we are hypothesizing, we're asking if the chocolate somehow influences Nobel Prizes. Y variable is Nobel Prizes. Where and group by we're going to leave empty. You'll probably have to click next. We're going to perform hypothesis testing. If we wanted to, we could do confidence intervals. I'm really not sure why they don't allow both to be done, but such is life. Later on, we're going to predict the Nobel Prizes in Denmark using their own chocolate consumption. If we wanted to, we could put in the Denmark data here, or the Denmark number of bars, which is 86. But I go through it by hand. But I'm going to go ahead and do 86. This will also give me a confidence interval for the prediction. And really nothing else needs to be done for this problem. Or in general, nothing else needs to be done. We could do a graph if we want. So yeah, might as well do a graph. Default. This should be good. Compute. So here we go. Here's the first page. This gives all the output. Second page gives the graphic. Gives kind of a weak version of the one that's provided in the example. But again, we see in this graphic, there's a positive relationship, at least in this sample. So let's go back. There's 3 sections to this. There's 4 sections to this. The first section is the linear regression results. The second is called the regression table. Here's the regression table. Third is the ANOVA table, or the analysis variance table. And the fourth is that prediction that we asked for Denmark. So, some important things in this first part. Double check that the dependent variable that we wanted actually would be Nobel Prizes. And again, dependent variable is your Y variable. Independent variable, double check that we really did want it to be chocolate. Independent variable is going to be your X variable. This line is the actual line of best fit. So the prediction for Nobel Prizes is negative 0.5496 plus 0.0255 times the amount of chocolate eaten. Gives a sample size of 23. There were only 23 countries. Notice 23. R is given, the correlation coefficient. It's 0.686999627. That will be important if you're going to use tables to determine if that is statistically significant or significantly different from 0. The R squared value is given. Again, the interpretation of the R squared is that's the percent of variation explained by this model. So here, R squared is going to be 47.196388% of the variation is explained by this model. Percent of the variation in the Nobel Prizes is explained by including chocolate in the model. And this bottom one is S sub E. It's the estimate of error standard deviation. S sub E is usually used just for estimating or calculating other standard errors. So that's the first part of this, first of the four. The regression table, here it's labeled parameter estimates. You got the intercept and the slope. The slope is also known as the effect estimate, the effect. So the estimate for the effect of chocolate on Nobel Prizes is 0.025482321. So as the chocolate consumption increases, the number of Nobel Prizes per million people increases. There's the test statistic. It's a t-test statistic. And here's the p-value. Because the p-value is less than alpha, we know that the slope in the population is non-zero. It's a positive slope. So in other words, we are very sure, again, because this 0.0003 is less than alpha, we are very sure that there is an effect of chocolate on Nobel Prizes. Of course, there's other assumptions underlying this, but those are not important for these bare calculations. Analysis of variance table is usually used just to look at whether or not the model itself as a whole is statistically significant. Again, because the p-value is less than alpha, we know that this model does give us information about the dependent variable. If this p-value is 0.527, then we'd say, okay, this model gives us nothing significant about the dependent variable. And then the predicted value. We said x was 86, which is the average chocolate consumption per capita in Denmark. This is the predicted y value, so that is the predicted number of Nobel Prizes per million people in Denmark. We actually have confidence intervals. This is the confidence interval for the mean, for the expected value. It's the confidence interval for that 1.641877. This number is usually not used. This is the prediction interval. It's not a confidence interval. It's a prediction interval for the next new data point. So if somewhere out there I get a country that's also 86 in terms of chocolate consumption, there's a 95% chance that that specific country is between those two, is within that interval. Notice that we're talking about a specific country, whereas the confidence interval is talking about the average of all the countries. Prediction interval is for one new country. Confidence interval is for the mean, for the average. And again, here's the graphic. And so that tells us an awful lot. It tells us that, well, assuming that there is scientific theory underlying all of this, which statistics doesn't really care about scientific theory, it just deals with relationships in the data. If there is scientific theory explaining why chocolate should affect Nobel Prizes, then we've just shown that there is a very strong relationship between the two variables. Very strong positive relationship. And that's it. So hopefully this was helpful. If not, leave some messages in the discussion board and we'll take care of it. Thank you very much. Have a good night.